So good afternoon. So today and next class we'll cover the steel. So we cover the fabrication process and steel as the structure member and steel as the trading member. So we'll look at the several steel material through the lectures. So you can learn what kind of steel you can use for the structure, and you can learn what kind of a structure trading you can use for your design. Also, we will discuss the several technical methods to connect the steel to different material. Okay. So first, let's talk about what is the character of the steel. Steel is a non-combustible structural material. There is three common non-combustible material. What is three non-combustible material? The first we learned the brick and concrete and steel. Okay, it means it is available to using for the type 1, type 2 construction. It means it is available to designing high-rise building. Also, the steel is suitable for the building of the all size and types. So it means it is available to build from residence to the tallest skyscraper. Okay, so before we discuss about the character of the steel, we just looking at some history first. Okay, so let's look at the steel history. So steel is spread out during the industrial period around the US and Europe. The popular uses of steel demonstrate the ability of an architect and engineer to reach for the new height. So you can see the image Eiffel Tower. The comparing to the surrounding scale, it is reached a totally new height. So steel is available to make out this kind of a structure. The development of steel is available to make a huge space and make availability to occupy huge number of people. You can see the project here, the Crystal Palace Hyde Park, London, for the Great Exhibition of 1851. This long span development is available to make a huge open indoor space. It actually impacted the railroad station and the exhibition space, and also more design. So it is making up another level to occupy people in an indoor space, and it is making another monumental level to use this steel structure. So next one, the technology is available to build high-rise building. It changed the scale of the city. The lots of high-rise building constructed in New York, such as Empire State Building and Chrysler Building, during early 20th century. The steel is available to making this high-rise building. So from the region, the building grow taller as the technology development, and consequently the city become denser, and the popular uses in the steel structure introduced new architecture scene and urban form in early 20th century. So after inventing the steel and elevator, now it is available to build high-rise building. So it means it also changed the overall urban form. It making a much denser and higher of the city. So it means it makes the megapolis, the urban form, basically from inventing the steel and elevator. Okay, so I just wrote the one kind of a video to introducing about the brief history of the steel, and I think this is kind of pretty good the summary yourself to understanding about the history, and then we discuss about the steel type after this documentary movie. Okay.
The Industrial Revolution transformed the way we think, work, and live forever. The Industrial Revolution was an increase in production brought about by the use of machines, characterized by the use of new energy sources. It originated in Britain between the 18th and 19th century. The Industrial Revolution caused major changes in agriculture, manufacturing, mining, transportation, technology, and our main focus, architecture. So how did the Industrial Revolution affect architecture? The quest for neoclassical aesthetics turned into a search for an architecture that made use of the new industrial process and materials. Rather than beautifully made buildings with intent to impress, buildings were developed with the possibilities granted by new technologies and materials, especially iron and steel. In place of the quest to develop impressive buildings, the exploration was targeted towards buildings and designing efficient spaces that could efficiently and economically be replicated on a larger scale. With the advancements of the Industrial Revolution, architecture and construction became more affordable. This was especially owed to the ability to prefabricate architectural elements and building materials. Many people in the middle class were now able to afford architecturally designed homes, and architecture was now able to accommodate the growing urban populations.
This is quite evident in materials and efficiency. In 1800, the global amount of iron produced was 825,000 tons. 1 century later, in 1900, with the Industrial Revolution in full swing, the global production rose to 40 million tons, almost 50 times as much as in 1800. The drastic increase in iron and steel production and structures built out of these materials was largely driven by the expansion of railway infrastructure in England and other parts of Europe. As a side effect, more bridges were needed and the new materials allowed for larger spans to be covered. This early ironworks bridge was not like later iron bridges, but was rather more the direct translation of the stone arch bridge into one made of metal.
One of the best examples of the architecture that came about in the Industrial Revolution is the Crystal Palace in England. The Crystal Palace was not designed by an architect but by a gardener, Joseph Paxton. Even though there were 245 submissions for the competition to design a building for the Great Exhibition of 1851, none of them met the requirements. This gave Paxton the opportunity to present his idea. His design became known by the nickname Crystal Palace and was a direct result of the possibilities granted by the technological advancements in building processes and material during the Industrial Revolution. The structure was prefabricated, assembled on-site, and utilized large quantities of iron and glass, which is in a way similar to many modern buildings too. The exhibition was considered successful, but Paxton and the Crystal Palace did not find much praise until the 20th century, when modernist architects, and among them architects like Le Corbusier, reviewed this innovative structure and the application of manufactured parts. August 1850 saw the groundbreaking for the Crystal Palace. For the entire structure, only one size of glass was chosen, which hence determined the size of the repetitive units that made up the structure. The use of prefabricated elements in the modular design allowed the speedy build and the lower overall cost. 19 hectares of the Hyde Park in London were covered by the structure in a little under 9 months of build time. The central barrel vault transept was crossed by a long flat roof nave, and the building was completed on time and opened by Queen Victoria on 1st of May 1851. After the Great Exhibition, the Crystal Palace was dismantled and rebuilt in Sydenham on the outskirts of London. But the Crystal Palace was not just a relocated building. When it was rebuilt in 1852 and 1854, the structure used twice the amount of glass it had used earlier and was increased in size by the addition of 2 barrel vault transepts at the end of the original nave. The Crystal Palace remained an attraction until 1936, when it unfortunately burned down in a disastrous fire. The loss was felt locally and internationally, especially in the architectural community, and Le Corbusier was one among those who lamented its destruction. Today, there are no visible signs left of the Crystal Palace. However, London could soon see the return of this landmark, since in October 2013, a Chinese company announced its intention to rebuild the Crystal Palace as part of a £500 million project. The technological advancements and building materials that came about during the Industrial Revolution laid the foundation for the modern architecture of the early 20th century, and is the basis even of high-rise and skyscraper construction of today. With the further perfection of prefabrication of metal and iron-based materials, our generation has been able to enjoy further improvements of efficiency and costs with related to construction and architecture.
So you just kind of summarize yourself to understanding about the steel, right? The history. So now we talk about the steel type. So we already covered the steel type from the last semester, but let's review very quickly. So let's talk about the iron alloy that contain the carbon. According as the carbon content, the steel type and strength are the decided. So you see that here, the more portion of carbon means you can increase the hardness and brittleness of the iron alloy. So more carbon can be stronger, and less carbon can be more flexible. So let's looking at the cast iron first. So cast iron is the strongest steel type, having 2% to 4% carbon content. It has the strong compression, however, it is less strong in the tension. So during the 20th century, cast iron was used structurally and ornamentally, especially in New York City. They have a lot of cast iron facade, and also you can see the internal, the structure member found from the New York using the cast iron. However, it's too strong and then too stiffness, so that's why it reached a certain temperature. Sometimes it's brittle, which is the sudden failure. So this is kind of big issue to using the cast iron. So that's why people think about reduce the carbon content and then less than 2% carbon content, which is the medium and high carbon steel. It is strong in both tension and compression. So therefore, it is available to using the higher rise early 19th century. And the project here, the Reliance building in Chicago, they also using the medium and high carbon steel for the structure. However, it is still too strong. It's still hard to work. So that's why it's only available to making this boxy building. However, you just imagine about the contemporary architecture. It has very complex structure member required. So that's why the medium high carbon steel, it is not available to the making this complex form. So that's why it is reduced more the carbon content. The most common alloy for the modern structure steel, and then it's less than 0.3% carbon. It is great for the flexible form. The small amount of other metals improve the strength and toughness. It means low carbon steel, and it can including some other addendum material. You making them the stronger metal you can make. And also it is reasonably strong and highly ductile and easily welded. So that's why easy workability. It means it is to making the complex structure member. So please remember the mild steel, low carbon steel. It is most common the contemporary architecture structure the type. Okay. So next, wrought iron. It is the iron alloy with a very low carbon content. So this is the most common steel type before introducing the mild steel. It is tough, malleable, ductile, corrosion resistant, and easy to weld. So by this character, the wrought iron is used for the steel sculpture and ornament. So you can see the Eiffel Tower, they using the wrought iron. It is available to making this ornament, the steel member. But also it's pretty good kind of supporting the weight. That's why it's very popular to using this ornamented architecture at that. So now we discuss about the steel making process. So how we make low carbon steel. We learned about the low carbon steel. It reduce the carbon content to making the stronger the metal and also flexible metal. So let's look at some fabrication process. The first one. So there's two options to making low carbon steel. First option is the the oxygen process using the oxygen converter. It is also called as the oxygen converter process. So this is boiling method. So let's looking at some process here. The first things you need to be process. You need to prepare the pot here and adding the script. So adding the scrap. After that, you have to be melting down. But this is some special the process here. They blowing the oxygen into the pot. So why we need to blowing the oxygen into the pot? Because this is a low carbon steel. You have to be reduce the carbon content. So means oxygen have to reduce the carbon content. So that's why you have to be blowing the oxygen. Then you have to be sampling. So after the passing the sampling, you need to be tapping out the pure low carbon metal. So after that, usually has some slag from the pot. So nowadays slag is using for the reusable material. So when slag and Portland cement mix together, you can make a low permeability concrete. So it is used for the dam and switch and tunnel nowadays. And also it also using for the structure pieces as well. So just remember slag, it can be using as some waste and reusable material. So next, the steel making type is EAF, which is electric arc furnace. The electric arc furnace is another option. It is furnace that heated charged material by electric load. The industrial arc furnace range in various size from the small unit about 1 ton capacity to about the 400 ton unit load. Okay, so this is a very similar as the previous one. You have a pot here and adding the scrap, and then it melting from the electrode here. And then after melting it, you can get in the pure metal here. And then, so if you need more the metal, you can simply adding the more scrap into that, and then another electrode operation, and then you can getting the metal here. After that, simply the tapping out to getting the pure metal, and then after tapping out, you usually having the slag, and then you just remember slag you can using for the reusable material. So now you're understanding after having the pure low carbon steel, we have to produce the architecture element such as metal beam and column. So how we creating the architecture element? So first, the fabrication method is casting. The steel casting is one option to making architecture metal product. So simply you making out some mold, okay? Then you're making the reusable mold, and then you pouring this pure metal into that, and then you can making the desired shape. It is available to making the pre-complex shape because depending on the mold shape. Okay. So next option is rolling mill. The prior to rolling, you usually having the steel block, so you need to reheat it to making the structure form easily. So when the metal reheated, it can be more malleable and more flexible. So means when the reheated the metal box is kind of rolling down through the roller, you can make in a desired shape. So depending on the roller type, you can make in the wide flange, you can also make in some plate, so you can just make in the various form from this roller. So if you want to making but very thin the metal plate, you have to be past several rollers to reduce the thickness. Okay, so just kind of bring some video understanding about the rolling mill better. So let's watch this one together, and then now we talk about some steel member type. Okay.
Steel is highly resistant to shaping when it's cold, and for that reason it is generally rolled whilst it's hot. To make sure the steel is at the correct temperature for rolling, it is fed into a furnace. Here it travels through several temperature control zones until it's at the correct temperature and ready for rolling. Whatever the product, the principles of hot rolling are the same. steel is squeezed between rolls until the final thickness and shape are achieved. To do this, the rolls must exert forces of tens of millions of newtons, equivalent to a weight of thousands of tons. The rolls therefore run in massive bearings mounted in housings of enormous strength and driven by powerful electric motors. These are known as mill stands. The layout of a rolling mill can vary from a simple single stand mill to several stands positioned either side by side or in a line. The mill rolls themselves can either be plain for flat products such as strip, used for products such as cladding, or profile for sections, beams and columns for use in construction. Mill stands have various roll arrangements depending on the product being rolled. The simplest arrangement is a two-high stand, used mainly for long products such as sections. For light sections and bars, three high stands are sometimes used, with the steel passing one way through the bottom gap and back through the top gap. Four high stands have two work rolls in contact with the steel, supported by larger backup rolls to prevent distortion caused by the rolling face. These give greater accuracy for rolling flat products, such as plate. Universal beam mills include stands with both horizontal and vertical rolls bearing on the steel simultaneously. Rolling processes are computer controlled and monitored up to 50 times per second, despite.
So just kind of understanding about the rolling method. So from the last video we learned how structural beam is made from the factory. Now let's see the structural product forming by casting or rolling mill method. So from this hot rolling or the casting method, you can get into some lots of different structural member. The first structural member you consider the wide flange, which is the Y shape. So Y shape, wide flange, it is most commonly used shape for beam and column. Okay, so it is called the wide flange, which is a W series. So from here you can see wide flange from the top to the right corner. See here, this is a wide flange you can use. So this is always start from the W, okay, and then this is the American standard. This is a I-beam, but this is different as the W shape. The wide flange is mostly using for the major structure, and I-beam is the less efficient compared to the wide flange. It's because it's much narrower compared to the wide flange. So this wide flange using for the horizontal structure member and the vertical structure member. The horizontal member, it is using for the beam. It is taller and narrower profile. It is spanning elements such as the beam and girder. Here. And then it also using the vertical structure, which is the column. When you're using the column wider flange, it is usually for the pre-square shape. It's more square proportion. It's better suited for the using on the vertical column. So remember about the horizontal member, you need to be better efficient way using the taller and narrower profile, and the column is more efficient using the scale, the proportion. So you can see when you just kind of find out the wide flange, it starts from the W and then 10, which is number by number. But we have to be lead how you can lead and how we can understanding about this number from. So wide W means wide flange shape. And 10, which is, you can have any number here, you can find any number. 10 means nominally 10 inches deep, okay? So which is the height. What about the 30 mean? It's 30 pounds. It's not a dimension length. It is more about weight, which is 30 pounds per linear foot. So, but it's still nominal number. It is not the actual dimension. So basically from this size, you have to be find the actual dimension. So what is about the actual dimension from the W10 by 30? So you have to have steel construction manual book. I think it's pretty easy to get into this book when you work. So structural engineer provide, we have to be using the W10 by 30 here. So means architect, we using this dimension and then find the actual dimension to adapt to your drawing because it's affect the space. So how you can find out this actual dimension and actual number basically from the nominal number? So you have to find out from the steel construction manual book. Then when you open this book, you can see this information. Wow, it's lots of different information here. But you don't need to worry about the weight and any other thing. You only consider about the height and width. Okay? Because special height is important to designing your section because it impacts the ceiling height. So that's why you're simply comparing the height and width and length. I think this is the only effect to your design. Doesn't much matter about the weight, right? So when structure engineer provide a nominal number, which is a W20 by 40 whatever, so you can simply find this number from this book and find out the actual dimension and adapt to your design. Okay. So next type, which is the American standard, which is called as the I-beam. I-beam is less structure efficient than a contemporary wide flange, which is the W flange. The I-beam is called as S. Okay, S series. So S10 by 25, S10 by 26, whatever. So this is always start from the I. I'm sorry, always start from the S. Okay. So this is S series. Then now we talk about the channel. The channel has two different types. The C is American Standard channel, and MC is a miscellaneous channel. The C, which is American Standard channel, is usually for the structure member, and MC usually using for the indoor interior structure member. So you can see the channel type here. You can extract this, and then the American Standard channel is start from the C, and miscellaneous channel start from the MC. So where is this channel using for your structure? I usually using this channel for my curtain wall design. You see that this is a slab edge. This is a concrete slab edge. And then you have to be designing the curtain wall here. But how you support? There were several different options to support the curtain wall. But for me, sometimes I using this channel here, like this. So you can just design in a channel. This channel actually cover the concrete slab, and it also support the window weight, top and bottom. Okay, so means I redraw out. This is your concrete slab. And then just designing the channel. You also cover your concrete edge, and then you just adding the window. So means when you see from the outside, you can see this continuous profile. You don't see the concrete edge from the outside. So it means you can have in a much clear looking facade you can design. Okay. Next one. So you can also consider about the angle, the plate. This is angled plate. This starts from the L. Okay, the L 4 by 3 by 3/8, which is the 4 by 3 is the actual nominal number, which is the size of here and here, and then 33/8, which is called as the thickness. So you can also find out the dimension from the steel manual book. Also, this angled plate you can using for the curtain wall, similar as the channel. So you have some the concrete slab, and you can designing the angled plate here, and you can add the curtain wall here, and you can also see the very thin profile from the outside. Okay, this too is angled the plate. The next one is the T-shape. The T-shape actually basically from the wide flange. This is a wide flange, and then this make on the T-shape, which is the T-shape cut from the wide flange. So it's simply cutting the half from the wide flange to make this T-shape cut the member. So it is called as WT, okay, because W is wide flange and then T is cut, it's a T-shape cut, and then it is called as this one here. It's pretty similar as the wide flange. This 13.5 is kind of dimension here, but 47 is the weight of this member. Okay, so this member produced by cutting W27 by 94, which is the half of this dimension. Okay, so remember WT is half of the wide flange. So next one is the HSS, which is the hollow structure section. So HSS is mostly using for the structure column. It has the rectangular, square, and circular section. It's pretty efficient to support the weight. So you also having the designated name, which is a hollow structure section HSS. It starts from the HSS, the X by Y by thickness. Okay. Also, actually, you can find out the actual dimension from the steel manual book. So next one, the previous one is all about the hot steel. So means hot steel, it is used for the structure member. So now I just want to talk about cold formed steel. The cold formed steel is non-structure member. It is for the furring or the more about the non-structure member to support. So just kind of remember about hot formed steel I introduced here. This is all about hot formed steel. This can using for the structure member, but from now I introducing about the cold formed steel is not using for the structure member. It is just support to the cladding, support to the interior member. So cold formed steel, it is lightweight steel material, and the cold formed steel is the product made by rolling or pressing steel without heat or low heat. Okay, here without the heat or low heat. So hot formed steel require the heat or low heat to make the structure member, but cold formed steel without heat or low heat because it's non-structure member. So let's look at how we creating the cold formed steel in the factory.
Cold formed sections are used for a number of different applications, primarily associated with either the building envelope or light steel structural elements used in walls, partitions or floors. For building envelope, narrow strip steel is rolled into the sections required for purlins or sheeting rails that support cladding and sheeting. It is also pressed to form gutter profiles
It's also very
and
popular
flashings.
material for the metal stud, for your wall, for your
For
ceiling.
light steel framing sections, the narrow strip is rolled into C-sections that are built up into walls or whole modules before delivery to site.
Okay. So now we talk about the finish type. So what kind of finish you might consider for the steel member? So first one, stainless steel. Stainless steel is the most typical the steel finish material. It is long-lasting protection against corrosion and rusting. It is mostly using for the cladding and exposed exterior structure because it is long-lasting protection and also it's beautiful finish. That's why it is mostly you can find from the finish material. The next one is galvanized steel finish. It is great for the protecting the corrosion and rusting, and also it's much cheaper than the stainless steel. However, the finish is not a great looking because it's coated by the zinc. So that's why you can see this zinc pattern from the surface. So if you don't mind, you can use it for the exterior. However, people don't like about the texture and the finish looking. That's why it is mostly using for the structure member, but recessed structure member. It is kind of covered by the finish material. People no one actually can see this material. So it means it's more about the recess from the finish material, but still having the good protection from against some corrosion, and also it's the cheaper the price comparing to the other steel material. So next one is weathering steel. This is a weathering. What is about the weathering? The weathering is surface oxidation or rusting effect if exposed to the weather for several years. It means when it exposed outside, it keeps changing the color, it keeps changing the texture. So architects love to using this material because it can change some facade, it can change some texture and color by building itself. I think this is a very unique way to using this material for the design. So weathering steel is popular because it also provides very antique looking. It's pretty good to matching with any other architectural material. So nowadays kind of it is using very common architecture creating material to use. Okay, so you can see the Picasso sculpture in Chicago, and also you can just find out the different option to use. The best known under this weathering steel, named as the Corten steel. Probably you heard about the Corten steel. So this is I think biggest and most popular the weathering steel, the manufacturer. So just remember what the Corten steel is kind of weathering steel. So you can see I giving the one example using the weathering steel. So this one is Caxias Forum in Madrid, designed from Herzog and de Malon. Actually, they using the existing building. You can see the existing brick building here, and then they adding the program over the existing building using the weathering steel. So they just try to find and matching the existing context and existing building. That's why they're choosing the Corten steel for the new facade. And then they also controlled the porosity. Some part is going to open and then more perforation. I mean, it can get in the more light, it can get in the more ventilation through that. But sometimes you have to block out the sun and then some ventilation. They're using the solid panel here. So they're just kind of using the different perforated ratio depending on the program required. Okay, so this is you can just understanding about some system and design.